Hello, awesome people. This is Jude from Awesome LCG. Today, we are going to do a basic intro into procedural modeling and asset creation in Houdini. In this little tute, we are going to talk about creating this base vehicle asset and creating the UI with few controllers so we can modify this and all these wheel wells and the body reacts to it and even the ride height increases. What is a digital asset in Houdini? Once we create this car, and if we want to share this car with other people, and maybe they don't have the same knowledge that we have about nodes and stuff, but they still want to use this asset. In that case, what we can do is group all these nodes into an asset, and we can give some of the controls that are inside the nodes to the top of this guy. When you give them these controls, they can change this to whichever the way they like it. So yeah, that's we're gonna get an intro into creating this whole thing with the assets and controls and everything. Before we get on with this asset, let's cover some core techniques that we are going to use through this tute. Parenting is one of the basic things in 3D that's been used a lot, and let's check it out how it's done in Houdini. And this is going to be useful for our asset. Let's start by creating two cubes. Box. We're going to name it cube A. Then we are going to duplicate that, and we're going to name that cube B. Now we have two cubes, but it looks like one because they're on the top of each other. Let's move one of them to the side. Let's select cube A and translate it -2 times. And cube B +2 times. Okay. And let's also create a sphere. Okay. So let's say what we want to do is parent these two cubes to this sphere. All we have to do is connect these two cubes into this sphere. Sphere's output. Take. And now, if you move or translate the sphere, you can see the cubes are moving with it. That's parenting in Houdini for now. In Houdini, properties of different nodes are called parameters, and they are shown in here in the parameter window. When you select a node, it shows the parameters right here. So one of the best features in Houdini is the ability to link those parameters with different objects. Let's say we want the cube A and cube B to be the same size whenever we scale up cube A. For that, we want cube B to follow cube A. One of the ways is we can parent it, but we only want the scale. We don't want anything else. We're going to select cube A, and we're going to right click on the scale and click copy parameter. And then we're going to go to cube B, select the scale, and right click on the scale and press paste relative references. Oh, there's some sticks coming up on the cube B. Let's go and change cube A. Nothing happens because it's a different attribute. So you see, nothing happens because it's a different attribute. What we linked was this scale. So, yep, see? That's what it does. Let's take a closer look at what we have here. This is a very common thing in Houdini. So each of these channels have some kind of expression going on. So if you look at this expression, what it means is channel, this thing. So what this is, as I told you earlier, Houdini works like a file system. Starting off the address, cube A means this cube, SX means scale X means scale X, this one. So this one has the same thing, but it says SY means scale Y. And this one has scale Z. Okay, let's do something interesting. Now yes, cube B and C follows the scales from cube A. That's all fun. Now let's say we don't want the exact value, but we want double the value on this and triple the value on this. When this scales up by 1 unit, this has to scale up by 2, and this one has to scale up by 3. It's very easy to do it. So you select the B, scale up means Y. Let's just do it on Y for now. You put multiply by 2, enter. It's already like that. Then let's go to C and put multiply by 3. Okay, so now if you scale the Y, both of them are retaining the proportionality, and yep. bbox is a simple function in Houdini that calculates the bounding box around an object. It can give us what an object bounds are located in all 3 axes. This is what we are going to use to get our wheels to stay correct according to the size of the body. We have a box, we have a sphere, and inside the box we have the box and the null. We rename it as out. You'll see why we did that. So we want the sphere on top of the cubes. What we're going to do is select the sphere, go to translate X, type bbox, double quotes, dot slash, and we are going to, it's going to give us an option. We're going to select the box. You can select the different option using up and down arrow keys. So we are going to select the box, and then we're going to select the null that we remain that's inside the box, named out. And then we're going to go out of the double quotes, comma. So we are supposed to move this in Y direction, Y max, because it's top. If it's the other way around, if it's under, it's Y minimum. See, it's already showing what you need to do. See, all the attributes and everything is showing right here. So freaking easy. D, Y, come on, Y max. It has to be all caps. I don't know why that is. Okay, we didn't see any movements. So we have that, and we go to the box. Nothing happens. That's because we connected the attribute to the output that's inside here. So if we do any changes here, if we do any changes before this out node, they're going to reflect here. First of all, we don't see the sphere here because we are inside the box. Let's make sure we see that. So you go up here, this and show all objects. Now you see the sphere. And let's turn on the wireframe. Smooth shaded plan. Oh yeah, I guess whatever. You select the box and you scale it. See? No matter what you do, it always stays on top. Okay. You can use this bbox function in any way you want. And let's, as an example, we want this sphere to be on the edge, not in the middle, on the edge. So that means we want it to move in Y direction and Y plus. It's simple. So all we have to do is go to the sphere, select our function, because we are referring to the same object, right? So we select that, we copy that, we paste it on Z, and in here we have to change it to Z max because it's C direction and the plus direction, so it's max. Oh, see, now it's at the edge. Let's go into the box and change this. Yeah, see, awesome. This is what we're going to create. It's not a car, it's like a platform, but we have all these nice controllers where we can change our asset. Everything that's related to this asset is grouped inside this subnetwork. We go inside that and we get all the nodes and stuff. That's what I built. Let's turn it off. Press tab and start typing sub. And we get the subnetwork. And we are gonna convert it to an asset. We go to asset, new digital asset from selection. And you can rename this whatever the thing you want. I'm just gonna accept whatever there is. And you're gonna get presented with this type of properties. We'll get back to this later. We'll just accept it, and that's all. So you have converted your subnetwork to a asset subnet when you don't have any inputs on it. So let's start by making the platform. We go into the subnet, we create a geometry node, and we're gonna name this platform. We're gonna go inside it. Now we need a cube. Tab, box. Let's name this top. Let's put 4 here. For size 4. Thickness 0.05. 555. And width. We'll duplicate this box node by copying it. Control C, Control V, and we'll rename it bottom. Now we have to move it slightly to the top. We'll move it from this guy. Right now we can't see the top. It only shows the things that we have selected. For us to see both of them, we're going to create a merge node. Merge. Then we're going to combine these two. And then we're going to look at it from this. See, now we see both of them. Let's move these guys to the bottom. The bottom has to be slightly longer than the top. We need it to check the top size and then adjust accordingly. This is how we're going to do it. We're going to copy the top. We're going to go to the top and we're going to select size X. We're going to right click it and we're going to copy parameter. And we're going to come to the bottom, select the bottom. And on the size it says 4, right? We're going to delete the 4. And we're going to right click and say paste relative references. The top box's size X is connected to the bottom's X. So what happens now if we go and change the top size, the bottom one is also going to change. But the thing is, we need the bottom to be a bit longer than the top. So we're going to go to the bottom. We're going to add. So we're going to plus 0.5. Oh man, what did I do? Okay, let's bring this guy down and bring this guy up. So we have the top, we have the bottom. Now if you change the size of the bottom, the top changes, but it keeps the adjustment intact because we did a plus. If we did a multiply, it's gonna get multiplied exponentially. So this space will increase if we multiply it. But right now, because we did a plus operation, this length is gonna be the same no matter how long this is. Let's bring it down to something reasonable like 4. Let's add the supports. Let's create another box. The supports are the ones that are in the middle. Let's put another merge. Okay, let's look at it from here. Oh yeah, there we have the cube. Let's scale this box down. So I'm not going to do the positioning, like the up and down positioning from the box. I'm just going to get the shape and then we'll move it up using a transform node. So let's just get the shape first. We can adjust all the thicknesses and everything later. We need 5 of these supports in equal distances from each other. Let's first do the moving up part. Create a transform node. Now we're going to connect this here, delete this connection and move it up 0.1. We'll create another transform. And also, this is a nice thing about Houdini. So we have one box. We're going to create 5 supports from this one box. So whenever you break this branch and connect it back to a merge node, see, now we have 2 boxes from the same box. And the good thing about this is like now when we adjust this box, everything else, all the other 5 is gonna get the box from this guy. So we just have to adjust one and we don't have to worry about the others. We need this box to be at the corner of this guy. So we're gonna use the bbox function to do that. We're gonna rename this, move up, just so we don't confuse it. We'll call it support 1. Let's do a bbox function on this guy. So we try bbox, double quotes, dot slash. We want to look at the top box. Top is what we need. We're going to type top. when we select top, the same area, top. All these red and erroring because we didn't finish our expression. Top, comma, d dash, we're gonna get the x and it will be x minus, right? So it's mean, all in capital, and enter. A little thing about the bbox function is it's gonna align or move or do whatever to the pivot point. So it's not gonna care about the boundaries of this object. It's only going to care about the object that the function is addressing. So as if right now it's addressing the top, this guy. So it's not really worrying about what the shape of this box looks like. It's just going to get the pivot point from the middle. So that's why it looks like slightly out. We don't want it like that. We want it to be slightly inside. And we're going to reduce 0.1. Oh, my bad. So it's already a minus version. So we are going to just add. Right now it's aligning with the top. And we need 5 of those. So we're going to copy the support one. Here we're gonna, so this is the other side of it. Let's connect it here. So this is gonna be x max and -1 lala. Okay, and we need something in the middle. We got the third one. First, let's connect it so we can see when we do changes, it's happening. And divide by 2. And we got it right in the middle. So the distance from here to here, but divided by 2. That's why it's in the middle. And we're going to do the same thing for this guy. And let's connect it. So this would be min. Nice. So, yeah, we have we have a lot of nodes. Oh yeah, and the middle one is always in the middle. It doesn't have to be moved. So that's this connection. Let's see what it does. We go to the size. See, the small boxes are not scaling up. It is just moving with the top. Let's save this guy. Control S. Let's go back to our subnet. Now we out of the geometry node. You can see the supports are not there. That's because we are weaving this from this merge. This blue color thing shows where you're weaving the node graph from. We don't want this. We want to have a place where it should be like, okay, this is the final place for the weaving. So we're gonna create out node, out in capital. Put the view right here, and we go out, and we have the whole thing. Cool. Let's make the wheels. Create another geometry node. For some reason, let's rename this guy wheel. For some reason, for me, it's really hard to talk and do Houdini stuff at the same time. I don't know why. I mean, I don't have that problem with Maya. Maybe because I'm still new to Houdini. And we are going to create a tube. It's in the middle looking up. We need it to look z-axis, polygon, columns. Oh yeah, end caps. Nice. Let's get the threads that are supposed to be right here. For that, we have to select those things. Because we are trying to follow a procedural workflow, we don't want to go and select them by hand. So what we're going to do is we're going to select those faces by the number of the face. So we are going to click this. It's going to show all the number for the each face. We're going to create a node called extrude. And then we're going to connect it to the cylinder. It's happening, but it's happening to everything. See? We just want to select these guys. In this group, we are going to type the number of the faces that we need the extruding to happen. So we don't want any extruding happening on these 0 and 1, these two sides, but we want these, not 0 and 1. So it's 2 to right now. This has 26. Well, we may increase the columns, so let's put 100 there. In case we increase, so counted for that. Oh, see? Now we get it. And we need these to be separate, so we turn to individual elements. Bring this in a bit and insert. Okay. We need that, and we then need the inset. So we have a problem now. Now we need to select these, but not these or these. We can go in and like type each of these numbers, but we have no time for that shit. What we're gonna do is, on our poly extrude node, we get options to output groups. So it has a group called output front. So that's all those front faces of it. Output back is back. We don't need it right now. Output side is these guys. So we turn on the front group, and now we're gonna do another poly extrude. When we turn this front group on, it's gonna create a group of faces. It's a selection set if you're thinking in my terms. A selection set or a face set. We can change this to something else, but right now we're not going to because we like it. We go to the second extrude on the top, right here where we type the numbers. We can select the group that we just created. We do an insert. It's only excluding the inside, and then we need them to go in. When we're gonna copy this guy, connect, and it's not gonna be an insert, it's gonna be an distance thing back in. Okay, we have our wheel. So that's all the thread stuff. Now we need the rim. For that, poly extrude, connect it right here, and we know what we're gonna extrude. We're gonna extrude 0. Right now it's not a group, it's a face, so it's face 0. We're gonna do an inset and move it slightly out, and we're gonna copy and paste, and see all the numbers are going crazy now. So we're gonna rename this extrude to something else because we already have a group with the same name coming from this guy. So we're gonna change this to rims. We go to this guy, and then we're gonna select the group rims. See, we have this guy. So we're gonna insert a bit and move it in. Now we have a rim. Why does this looks like that? What's wrong? Oh yeah, see, we have 0 selected and it's affecting something. So we have to make sure we delete everything and select the rims correctly. So we have this right now. Everything is looking good. Let's create an output node, just like what we did last time. Out. Connect this guy here. So this rim looks pretty good. The wheel looks good. Okay, sometimes when you extrude and do polygon operations, the normals can get messed up, and it's easy to fix it. We are going to add a normal node, and it's going to take care of all the normal problems, and it's going to give new normals to everyone, and it looks good. Okay, so let's view our wheel from the out node, and let's go out. So now we have a wheel and a platform. We want the wheel to be right here. When we scale up the platform, like increase the width of the platform, the wheel should react to it. So let's get that thing working. Let's create a null front location. Okay, and we're going to create a geometry front wheel location, front wheel location. Okay, and we're going to add a geometry node, call it left, and we go into the node. So rather than creating a new wheel in here, we already have a wheel. We want to bring in this wheel into this geometry. So we are not creating a new wheel. This guy is referencing it in. So we're going to create object merge node. We're going to type merge, and we're going to get object merge. Now we are going to select the wheel from the outside in here. We click this guy, and we can select the wheel, and we press accept. Let's go and turn this guy off so it's not confusing. So yep, that's the only wheel we are seeing right now. So we want the wheel right here. This wheel is parented to the front wheel location null. I want to select the null and move the null, and we want this to be right here in z-axis. We want the wheel to react to this box. We are going to achieve that with a bbox function on this. So let's do that. So the axis we need to move is z-axis. That's what we want. So we're going to create a bbox function on the wheel. Bbox double quotes. We are going to address the platform, which is this node. So we are going to quote double, and let's type platform. That's a platform. And we want the end result of the platform. So when we go into the platform, when we have a slash right here, it's going into the platform, and it shows all the nodes that are inside this platform geometry node. And we want to select the out, because that's like our final out. Before we want to move it in z plus axis, we're going to put d Z max and press enter. Right now it's kind of cutting into the geometry. I don't mind because wheel wells, we are gonna make them later. To create the right wheel, we are gonna copy this Control C, Control V and rename it right. We want it to be the opposite. So we are gonna select the right and we are gonna change Z max to Z min. The rims are facing the wrong way, so we are gonna rotate it by 180 in Y. And let's go check it out whether it works correctly. We go to the platform and we just put a transform node just to check how it works. We'll just put a transform node in here and scale it in Z. Oh wow, okay, I just moved it. It works on move as well. So see, the wheels are changing based on the width of the platform. Let's turn on the grid. So as you can see right now, the wheels are not planted on the ground. We want to make sure no matter how big or small the wheels are, we want to make sure that the wheels stay on top of the grid. Front wheel location controls the position in x-axis. We want another now so we can control the y-axis movement of the wheels. So for that, we're just going to copy the front location. We're just going to add it right here. And then we're going to rename it to front axle. Oh yeah, that's because we have double transformation. So we have point this value here, and on this we have the same value. So let's just remove it for now. So we want the wheels on the ground. First, we have to check the size of the wheel. We're going to use the same thing, bbox function. So click on the wheel axle and it's translate X. So this guy, so bbox double quotes dot slash, that's the left wheel. And we're just taking the left wheel from the outside. In bbox, we have several functions. We have something called size. So size means the size of the object from like top to the bottom. Bbox left D Y, right? We are looking for the Y. Y size, enter. So we have the wheels way off the ground. It's because it's taking a whole wheel length of space to the top. We want half of it. So we're gonna divide it by 2. Let's see whether it works. We can just go into this wheel and boop, see how nice that is. Let's get our body to react to the size of the wheels. So when we scale the wheels up and down, the body should follow that. We want the platform to be on this level, not on the ground. And when we scale up the wheels, we need the platform to follow them. So let's go into the platform, create a transform, and let's name it ground clearance. Spellings are wrong, but it's still gonna work. And we're gonna connect it right before the out node. That's what we want. But we need it to be driven based on the size of the wheel. So let's bring in object merge, and we need our wheel. Accept. We'll just call it wheel. And you should care about the capitals and naming and all this stuff when you're making something huge, but this is a super simple thing, so I don't care about the spellings. Let's go here, start typing a bbox, double quotes, dot slash. It shows everything that's in the platform node. That's why we brought in the wheel, and that's what's shown right here. We select that guy. We can use the same thing that we did for the wheel height. So it's gonna be y size divided by 2. This doesn't look right. Oh yeah, because we didn't type the D underscore. Okay. See, now it's working. So this ground clearance node is getting the height from the wheel size divided by 2. Let's go increase the wheel size and see how it works. Oh yeah, nice. The wheels looks a bit thick. Let's thin it out a bit. Yeah, a bit more. Yeah, right now the wheels are going through our platform. We need nice wheel wells for the wheels so it don't go through it. I made a little mistake when I make the ride height adjustment. I created a node inside the platform and got the ground clearance working inside the thing. I'm gonna correct it. Let's copy this. It's gonna be the same expression, and let's delete this guy. And we're gonna bring that ride height adjustment onto the geometry. Translate Y, and looking at the wheel right here, and then the size of that divided by 2. Let's go in and get these wheel wells working. Let's go into the platform and create a cube. Cut out. You can't see it because we're viewing it from here. So let's put a temp merge node. so we can just see everything together. First, we need to make sure this box is the same size as the wheel. For that, we use bbox wheel in dx size. We are gonna copy this across 3 axes. Now we want this box to be moved right here. We want it to be in the correct location to make a cutout. So we're gonna use a transform node. We're gonna call that transform node front. This is the value that we're gonna have to change, but we want to get that value from this locator. So we're gonna go back to the subnet and we're gonna get it from this guy. Copy parameter. This is the X translate. We go back into our front transform. Paste relative references. We got him right there now. So if we change the front location, now the box will also move. Now we want to make sure the box is right here. We need another transform node for that. It's better to keep different axis transforms in different nodes. Right now we need it because we have 2 wheels, so one for the left and one for the right. Translate z bbox double quotes // out comma d z max. Why is it not working? We were kind of creating a loop right here. So all you need to do is break this guy, okay, and we know it's in the right location. So let's get rid of the node, this merge node. But what we need is a cutout. So the best way to do cutouts, booleans, and we're gonna add a boolean node right here, and this one comes to the first one, and the cutout comes to this guy. Right now it's set to intersect. We're gonna put it to subtract. Okay, so we need to get this output and get the width of this to get the scale right. So for that, we are gonna create a null before the boolean platform width, and we are gonna address platform width. This transform is getting the width not from here but from right here. We don't really want the wheel wells to be this close to the wheel. We want some space between those. So we are gonna add some values onto these. X, we're gonna add plus 0.2. We need the z as well. We're gonna put the same value, plus 0.2. Let's create the right side. We're gonna copy the left and rename it right, and we're gonna have the same expression but an inversion. So we can just put a minus at the end. This box and this box, we want both of them to be cut out of this guy. So we're gonna merge them first and then send it to the boolean. And we have cutout. Go and see whether our cutouts work with the locations. If I increase the wheel size, bloop. Let's save this just to be safe. Let's get some colors on these guys. Go to the platform, create a color node and change it to primitive, so it's like faces. Put a red color, and we want the bottom to have the same thing. We can copy this and paste it. Now if we change this is not going to change, so we are going to link these two guys. Select the first one, copy parameter, select the second one, paste relative reference. So if we change this guy now, we get the bottom one changing as well. Oh, let's make this blue. Now we need our supports to be some other color. Copy, paste, link to this guy. We need a darker color on these. So the platform looks good. Let's color the wheels. Let's do it above the normal node. Red wheels. Let's go in and create the controls, so we don't have to go into each node and adjust stuff. We can adjust all our attributes from the top subnet. Select our subnet, right click, type properties. If we go to parameters, these are all the attributes we have right here. So transform, we have transform tab. We have subnet, we have subnet tab. First, let's create a new tab for our controls. Left click, drag the folder onto the root, and let's rename this guy CTRL. Okay, if we accept it, we're going to lose this window and the things are going to get applied, but we don't want to lose this. We need more stuff to be there. So we're going to place apply. We have a new tab, controls. We need to add the control for the wheel radius. We don't want to dive into the wheel every day. We want to create control. So the wheel radius is a float, which is from, we can select all the parameters from this list. Single float, we're going to grab that. Left drag onto controls, and we have a new parameter. We can change this to wheel radius. Each parameter have two things: name and label. Name of the attribute. Label is what's going to get shown up right here. It can be it's like a nicer name. We're just going to name it like a wheel size. In the name, you can't put spaces, but in the label, you can put whatever you want. So let's put a range from 105 wheels to 10. Let's apply and go back to our controls. So yeah, we have the wheel size now. Let's connect the wheel size parameter to our wheels. Copy parameter, go into our subnet, wheel, tube, radius scale, right click, paste, relative reference, go back up. We need to see our screen now. Let's accept. Bring these guys up. Oh yeah, see? That's few more controls. So now let's bring in the body size. We go into the platform. Let's get the top. Because we connected the top to the bottom, whenever we increase the size of the top, change the size of the bottom as well. And for the width, we didn't do that. Let's get that working. Copy parameter, paste, relative references. Okay. Now if we change the top, we change the bottom. Okay, we need the supports to do the same thing. Let's do the same thing on this guy. Delete. Paste, relative reference. We increase this, everything is moved. So what we want this attribute, this parameter in our controls. Left click and drag it onto the controls. That's all. Body size. And we apply, we go back to our subnet, object level. We are not planning to do that, and we don't want this control in the front. We're going to go to the parameter that we just added, and we're going to change it from float vector 3 to float vector 2. So we only have two values. And we're going to go here, and right now, the second float value is going to size Y. We're going to change it to size Z. Okay, which apply, and it's super thin because it's 0.1. Let's put it to like 2. Okay. So we got the controls for the body size. We need a control for the wheel distance. Let's use manual float for that. Left click, drag onto controls, wheel distance, apply. Wheel size, wheel distance, copy the parameter, go into our subnet, front wheel location, delete this guy, paste, relative references. Now these were our front wheels. And if we change the wheel distance, actually it's moving to the back. We don't want that. We want it to move to the front, so we need inversion of this guy. So we put a minus at the end. Okay, let's get the colors as well. This is pretty simple. We're gonna left click drag the colors onto body color. Then we have the supports. Left click drag onto the controls. Support. Now if we go back to our, okay, let's add the wheel color as well. Wheel color, wheel color, wheel color. Left click drag, wheel color. Body supports wheels. Change the wheels to yellow, like yellow. Okay, we have the colors working. We have the wheel distance working. Now all we need to do is get the other two wheels working. Let's go to the subnet. We're gonna copy this whole set. I'm gonna paste it. So right now this is not front anymore, this is the back wheels. BSEK back. And we want this value to be the opposite. So that's what it is. So this is not a front axle anymore, this is a rear axle. And what else? We don't have the wheel wells. Let's get the wheel wells for the back. So let's make some space here. Copy, paste. Basically, the wheel size are the same, so we can get the same cube. Delete this guy. We don't need too many nodes. This is not the front anymore. This is the back. So we are getting the location from front wheel location. We should change it to the back wheel. Let's connect these guys first. Let's go to the back wheel. Copy parameter. Back. So if you want to clean something that already has something on it, You right click and delete channels. And now it's all clean. We're going to delete whatever the numbers we have, paste relative references. Back wheel. Now it's pointing to the back wheel. Cool. Let's accept this guy because we don't need him anymore. Okay. That's all for the asset. That's all, guys. I hope you guys learned something from this dude. Please subscribe and like my video. And if you have any other questions, please put it down on the comments. Thank you.